Everyone knows that a giant rock from outer space hit the planet millions of years ago and wiped out the dinosaurs. Now, with advanced technology, researchers have been able to put together a new timeline showing what really happened. And not only this, they think they know where the giant asteroid came from. Is Earth the target for another huge space rock? And would we be able to survive? You'll be surprised, and probably shocked, at what NASA astronomers recently discovered. So, now get ready to experience the disaster that almost wiped out life completely on Earth. The giant asteroid's impact into shallow waters in the Gulf of Mexico 66 million years ago was bad enough. But then an amalgam of additional disasters ensued. Rocks fell from the sky, wildfires ignited, and tsunamis inundated distant shorelines. The researchers found that the first day of the Cenozoic was peppered with cataclysms and released a new record of this day of chaos in the Proceedings of the National Academy of Sciences. Their timeline was developed using high-resolution photography, microscopy, computed tomography imaging, and magnetic measurements of hundreds of feet of sedimentary rock recently recovered from Chicxulub, one of the largest impact craters on Earth, and it all began like this. Nethri, imagine you were somewhere in North America about 66 million years ago, when dinosaurs ruled the Earth and you were looking up at the night sky. You would have probably seen what appeared to be a bright star shining off into the distance. But if you watched this peculiar light for an hour or two, the object would seem to grow in brightness, but barely move. What you would be looking at is not a star, but a huge asteroid somewhere between 10 to 15 kilometers wide, 6-9 miles on a direct intercept course with the Earth at 72,420 kilometers per hour, 45,000. 6 hours later, the asteroid plows through Earth's atmosphere, heading straight for where the Yucatan Peninsula is today. At impacts of that speed, Earth's atmosphere acts like water. Smaller space rocks called meteors hit the atmosphere like pebbles thrown into a pond and decelerate rapidly at high altitudes, burning away from the friction of the atmosphere, while some bigger pieces of rock survive and fall to Earth. But the mountain-sized Chicxulub asteroid hits our atmosphere like throwing a boulder into a puddle. It maintained its velocity and plunged through the entire 60 miles of atmosphere in just 3 seconds. The asteroid shrieks over Central America, emitting the mother of all sonic booms that would shatter eardrums across all the continents. The dinosaurs were likely terrified and running in all directions, having no idea what was just about to happen, but if any animal was close enough to see the asteroid, they would have been instantly vaporized within minutes. In fact, except for sea turtles and crocodiles, no four-legged animal larger than 25 kilograms would survive. The mountain-sized space rock falls so quickly that the air itself cannot escape. Under intense compression, the air heats to thousands of degrees almost instantly. Before the asteroid even hits, compressed, superheated air vaporizes much of the shallow sea that covers the Yucatan. Milliseconds later, the rock plunges through what's left and slams into bedrock. In that moment, a chain reaction of events occurs. The impacting asteroid exerts so much pressure on the Earth that soil and rock flow like fluids. The flowing up and down movement of the Earth is like the double splash of someone doing a cannonball in a swimming pool. The initial splash in all directions is followed by a delayed vertical splash when the cavity created by the asteroid rebounds to the surface. The first wall of Earth gouged outward at the moment of impact is more than 32 kilometers high, 20 miles. The impact hole nearly breaches Earth's mantle, and when the cavity rebounds to form the delayed vertical splash, the Earth rises at over 1,600 kilometers per hour, 1,000 miles to heights taller than Mount Everest. Within minutes, this mountain of debris almost entirely collapses in a series of secondary explosions, leaving behind a smaller mound called a crater's peak ring. For at the same moment the asteroid strikes the Yucatan and applies its pressure to the bedrock, it converts the kinetic energy of a rock traveling 16 kilometers per second, 10 miles per second, into searing heat in an instant. The Chicxulub impactor delivers approximately 1 septillion, 300 sextillion kilojoules of energy, more energy than 1 billion Hiroshima atomic bombs. The kinetic energy transferred by the asteroid to the soil, rock, and air excites the molecules to temperatures far hotter than the surface of the sun. The heat rips electrons from atoms, ionizing the air into an expanding fireball of plasma in excess of 10,000 degrees, turbocharged with vaporized rock that is blasted out at hypersonic speeds. Heated, rapidly expanding air and near-instantaneous conversion of Earth to gas, combined with the impact shockwave itself, forms a massive blast wave of pressure expanding outward at more than 1,600 kilometers per hour, 1,000. If this asteroid hit the same spot today, the blast wave would vaporize you in Texas, deafen you in New York, and blow out glass windows in Buenos Aires. The Chicxulub impactor rings Earth like a bell. Waves in Earth's crust radiate away from the impact zone at 4 kilometers per second, 2.5 miles per second. These waves then trigger fault, lipping earthquakes across the continents. If you were on the other side of the world, you would feel the ground shaking 30 minutes after impact. The impact triggers tsunamis as high as skyscrapers. The first of them hit Gulf coastlines within the hour. Waves ranging from 600 feet to perhaps as tall as 1,000 feet smash into what is now Mexico and the southern United States and flood tens of miles inland. The waves temporarily reverse the flow of rivers, rushing up riverbeds like 30-foot tidal bores. Tsunamis smash into the eastern coast of the United States, and 6 hours after impact, max out at 600-foot, high walls of water that slam into Europe, Africa and the Mediterranean coasts. Within 15 hours of impact, waves arrive on every coastline on the planet. Depending on local topography, the ocean sweeps away anything in its path and sucks it back to the sea when the waters finally retreat. It already sounds like Armageddon, but even more disasters are on their way. When the big rock strikes, its splash accounts for 25 trillion tons of Earth that it launches on ballistic trajectories, some at speeds that exceed Earth's escape velocity. These rocks exited Earth's gravitational pull to either orbit the Sun, and some of this material probably reached the Moon. But the majority of ejected debris returned back to Earth within the hour. These glass-like chunks, called tektites, some as large as buses, but most the size of marbles, pelt the Earth at speeds ranging from 160 to 320 km per hour, 100 to 200 mph in lethal quantities. Regardless of where any remaining dinosaurs were on Earth, they were hit with this fiery hailstorm. But these glass bullets didn't need to hit the dinosaurs to be fatal. As these tektites fall, their friction with the atmosphere emits enough thermal radiation to set fires across the planet. By some estimates, the combined heat of the returning embers heats the planet to the equivalent of an oven set to broil. Most of the world's trees burn, which is perhaps why the only bird species that survive the impact are those that nest on the ground. Of the few larger land animals to avoid extinction, nearly all have some means of escaping the heat. Either could burrow like small mammals, snakes and lizards, or escape into water, like crocodiles or turtles. Even if the poor dinosaurs were on the other side of the world, they would have needed to find protection from the initial heat blast. In a final piece of terrible luck for the dinosaurs, Chicxulub happens to strike an area rich in sulfur. The impact ejects 100 billion tons of vaporized sulfur and trillions of gallons of water into the atmosphere, which then condenses into massive storm clouds and falls back as torrents of acid rain that acidified the oceans. The impact also ejected a significant amount of dust and soot into the atmosphere. This created a sooty layer that covered the Earth, stopping it from raining back down. And that becomes another big problem. The soot layer remains in the atmosphere, reducing the amount of sunlight that reaches Earth's surface by 90% for at least 2 to 3 years. The initial oven, like heat brought on by the returning tektites, is followed by a deep and long-lasting freeze. Global temperatures drop by an average of almost 50 degrees. The only places on Earth to avoid this deep freeze are Madagascar, India, and Indonesia, which were tropical islands during this time. In the global chill, evaporation almost ceases, dropping rainfall by 80%. Nearly every spot on Earth outside of these tropical islands dries into a desert. Where did this giant rock come from? And is there another one out there headed for us? Researchers have suggested that the Chicxulub asteroid likely originated from the outer part of the main asteroid belt, situated between Mars and Jupiter. It was likely a carbonaceous chondrite, a type of dark asteroid rich in carbon. Studies suggest that fragments from this region can cross Earth's orbit and hit the planet once every 250 to 730 million years. Judging from this, it's not a matter of if we could be hit by another giant rock from outer space, but when. On Saturday, December 11, 2021, a 330-ton asteroid named 4660 nearest screamed past Earth at a speed of about 23,700 km per hour, 14,719, coming within approximately 3.9 million kilometers, 2.4 million miles. While you might not think that is very close, any slight deviation in its orbit could put it on a direct course with us and smash into the Earth in the future. Astronomers are tracking this potentially hazardous rock and say it will come within 1.2 million kilometers, 745,000 miles of Earth on Valentine's Day in 2060. Who buy your flowers and get those proposals done early? Just in case, keep in mind the asteroid that caused the Chelyabinsk explosion in Russia in 2013 was just 20 meters in size. The bad thing is that we don't have any known way to defend the Earth from a giant space rock. However, NASA's DART mission, or Double Asteroid Redirection Test, set out to see if a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, causing a kinetic impact that could push the asteroid off a collision course with the Earth. DART's target was Dimorphos, an asteroid moonlet which orbits a larger asteroid named Didymos. The spacecraft successfully impacted its target in late September 2022. The collision changed the speed of the moonlet by more than anticipated, proving that this method of asteroid deflection is viable. Stopping a 10 km eyed or bigger asteroid hurtling towards the planet at more than 72,000 kilometers per hour will take a lot more than a small spacecraft impacting it. Perhaps the world would need to try nuclear weapons like in the movie Armageddon. Maybe you have an idea how we could stop a world-ending asteroid, and you'll become famous. Let us know what you think, and make sure to stay tuned here for more exciting stuff happening in our universe. One of the greatest illusions in life is continuity. 66 million years ago, the continuity of the dinosaurs had been going on for around 165 million years already, and it didn't seem this would change anytime soon. The world was warm and pleasant, and most of the land was covered with lush forests and an incredible diversity of trees, flowers, ferns, and trillions of critters. Dinosaurs were ubiquitous and had diversified into hundreds of species of all shapes and sizes. Titanosaurs, large gentle giants, shared the world with famous beasts like Tyrannosaurus rex or Edmontosaurus. Pectinodon hunted in the undergrowth while Edmontosaurus wandered coastlines and swamps. An ancient paradise, a world of plenty, full of life. 66 million years ago, maybe on a Tuesday afternoon, life was the same as it had been the day before or 1,000 years before or pretty much 1,000,000 years before. Things were good for our feathered dinosaur buddies. Until a tiny detail in the sky changed. If there were dinosaurs watching the stars, one night they may have noticed the appearance of a new star. A tiny dot that for many weeks slowly became bigger and brighter. Till one fateful day, it looked like another small moon in the night sky, and then it faded from sight as it dipped into Earth's shadow. For a few more hours, the illusion of continuity was upheld, until it was not anymore. In the morning, the object suddenly appears again, now almost as large as the sun in the sky and growing every moment, heading for the coast near the Yucatan Peninsula. It takes the asteroid only 2 seconds to pass through the thin layer between space and the ground to make contact, as it enters the atmosphere at almost 60 times the speed of sound. Let us stop time. Here we see the unnamed asteroid about to commit specicide. Larger than Mount Everest, it reaches from the ocean high into the atmosphere, higher than passenger planes would fly millions of years later. At this moment the world was one way. A fraction of a second, it would be fundamentally different. Let us make the transition. As the asteroid hits the shallow ocean and the bedrock below, the energy of billions of nuclear weapons is released all at once as the asteroid vaporizes. A flash of light illuminates the sky as an eerie bright white sphere grows over the Gulf of Mexico. Bedrock melts into seething hot plasma at tens of thousands of degrees Celsius. The thermal radiation from the explosion travels at the speed of light and immediately burns everything within a radius of about 1,500 kilometers, while the energy from the impact pushes so hard against Earth's crust that it loses all strength and flows away from the impact site like a liquid, creating a hole 25 kilometers deep and 100 kilometers wide. The ocean is pushed back for hundreds of kilometers, like when a kid jumps into a puddle. As the crust bounces back, melted and flowing crust forms a temporary mountain stretching 10 kilometers into the sky. An incredible amount of material is blasted into the higher atmosphere or even out into space, as much as 60 times the original mass of the asteroid. The violence of the strike is felt everywhere on Earth within minutes. A magnitude 11 earthquake, maybe the most powerful quake any living thing has ever witnessed in billions of years. It is so insanely strong that in India it might have shaken gigantic lava fields and caused volcanic eruptions that would last for 30,000 years and cover half of the Indian subcontinent with lava. Even on the side of Earth opposite the impact, the ground still moved by several meters. Nobody would sleep through this day. The gigantic explosion crashes against the atmosphere with unprecedented violence and causes a shockwave that reaches speeds of more than 1,000 kilometers per hour near the site of impact, similar to the hyperhurricanes on gas giants like Neptune. Middle America, basically any soil, vegetation or animal is just shredded into pieces and catapulted thousands of km away. Now, the formerly displaced oceans return. As the temporary mountain at the site of impact collapses, a ring of tsunamis as high as 1 kilometer, enough to cover all skyscrapers humans would ever build, heads in all directions. As they crash into the coasts of the continents surrounding the impact, they will drown thousands of kilometers of coastline. 15 hours later, some of the waves that get refracted around South America will still tower as much as 100 meters into the sky. But we still have not talked about the worst thing yet. A lot of the debris yeeted into space will orbit Earth for thousands of years. Some hit the moon or even Mars, but most of it comes right back. When things fall through the atmosphere at such speeds they get very hot, like hundreds of degrees hot. This happens to millions of tons of material everywhere. This rapidly heats up the atmosphere to insane temperatures. We don't know exactly how hot it got or how long this heat shock lasted, but there are two ideas here. Either the air was heated to hundreds of degrees for a few minutes, or to thousands of degrees for around 1 minute. In any case, the air becomes as hot as the inside of an industrial oven. How bad the global effects of this were is contested, but if enough heat reached the surface, a lot of plants and animals would have died very quickly if they couldn't bury themselves or escape into caves. The heat, together with raining debris, also may have ignited material on forest floors and sparked wildfires as the earth rotated under the searing hot plume. In a few hours, massive wildfires were probably burning around the globe. Some of them may have lasted for months and turned Earth into a horrifying hot hell version of itself. As the day of the impact draws to an end, many of the dinosaurs are already dead, but the worst is still to come. The gigantic plume of vaporized material reaches the upper atmosphere and spreads around the whole globe. Together with the soot from the burning planet and the aerosols generated at impact, the planet sinks into a deep darkness, with only the remaining raging fires illuminating the scenery. Whatever plants survive the firestorms will now be starved for sunlight as global photosynthesis is temporarily shut down. Within days, temperatures crash as much as 25 Celsius. The oceans were especially hit hard. The lack of sunlight killed over 90% of plankton, which form the basis of the food web of marine life. Ultimately, this would kill off the large marine reptiles and ammonites that used to dominate the seas. The biosphere the survivors now find themselves in is like an alien landscape. Ash, debris and the burned remains of the formerly lush and blooming life cover the ground. The sky is dark and it is cold and fresh food is scarce, while fungi thrive. For months and years, the planet will be a hostile and deadly place. The sudden global winter will last for decades. At least 75% of all species on Earth will just vanish from existence. And so, as the day ends, the world is suddenly different. Continuity that went on for millions of years is no more. The era of the dinosaurs is over. Just like that. Eventually, from the ashes of the old world, survivors emerged. Birds that are the direct descendants of the dinosaurs and mammals that would eventually become the dominant animals on the planet. Without the asteroid, who knows what life on Earth would look like today? Without the sudden disruption of dinosaur continuity, that completely changed the planet and all life on it, we might have never had the opportunity to become what we are today. It is not clear how long the human era will last. So far, modern humans have been around for 0.1 of the time the dinosaurs were. And in this short amount of time, we've achieved impressive feats, from making the world our own, to reaching space and splitting the atom. Yet our future, and our long survival, is not a given. If we are not careful, it could end in an instant, like the age of the dinosaurs ended. But in contrast to them, we know that our continuity is fragile, even if it doesn't feel like it. We can be prepared and be vigilant and hopeful. If we are lucky, our journey will go on for a long time. Speaking of journeys, we want to address something in the spirit of transparency. Purgesite has changed in the last 2 years. We've become more than a YouTube channel or animation studio and now also run a paper shop that sells hundreds of thousands of calendars, posters and notebooks. It's not a happy accident. Many of us have a background in graphic design. Paper products are our roots, and we actually started out creating posters, books and print infographics. We love that you can touch them, smell them, nerd about small details and printing techniques. Just like the channel, we started small and without great ambition. Step by step, we found the right printers and papers, learned about shipping and expanded our shop. We put a huge amount of research, love and hours into it, because this is the only way we know how to do things. We don't just want to make generic merch, but things that fit our mission of making science exciting and creating beautiful things. Things that persist and are made with high quality and love. Our shop gives us another outlet to do this, and as a nice side effect, has turned into our main source of income for everything we do on this channel, which also keeps us independent and our video free for everyone. So we want to build further on that and create more things that last. We just started a new notebook line called Pocket Log that we will expand on in the future. The first edition is a dinosaur-themed collection that will hopefully serve a future paleontologist well. There are loads of plans for sciencey stuff, more journals and calendars and infographics. Let us know what you would like us to make for your room, kids, classrooms and yourself. In the end, the things we do work because you like them, and because you enable us to put thousands of hours into videos and hundreds of hours into posters and journals. Thank you so much for that. We are looking forward to making fun, sciencey stuff for you, no matter if it will be a video, a poster, or something else entirely. Dinosaurs ruled the Earth for 160 million years. It seemed they would forever dominate the biosphere, but one day, their world was destroyed by a huge rock the size of Everest falling from space. This is the story of how the era of ancient reptiles came to an end. The last day of the dinosaurs' Earth 66 million years ago marked the end of the Cretaceous period of the Mesozoic era. The parts of the former supercontinent Pangaea had almost completely drifted apart. The planet looked very similar to its modern state, but not quite the same. South and North America had finally split. By the end of the Cretaceous period, Africa, Australia, and Greenland had the same shape as today. At the same time, the outlines of Europe and Asia were just starting to form. The mountain ranges of Siberia, Mongolia, the Andes, and the Cordillera were actively emerging. The Cretaceous period lasted 79 million years and became the longest period of the Mesozoic era. The planet's climate changed several times during this time. It was relatively cool by the end of this period. Ice caps had formed at the poles, and winters had become harsher. In some places, the temperature dropped below 10 degrees Celsius and as low as 45 degrees Celsius in Alaska. But still, the world was warmer than it is now. Lush vegetation covered the continent's surfaces. It was during this period that flowering plants emerged. Conifers, ginkgo, and other trees from previous eras formed thick forests, which also included modern-looking walnuts, ash, and beech. The sod produced by these trees made the top layer of soil more fertile for newly emerging herbs. With the advent of flowering plants, insects also had to evolve. Butterflies and bees started to fly, spreading pollen. Seeded fruits developed from pollinated flowers, providing food for many animal species, including birds. This was what drove the evolution of some herbivorous dinosaurs, as well as many mammalian species. The number of carnivores, ungulates, insectivores, and primates increased under these favorable conditions. Admittedly, they had not yet become as large as they are now. Most mammals back then were small rodents and predators. For example, a fossilized head of a 20-centimeter long Cronopio acutus was found in Argentina. This small mammal is called the saber-toothed squirrel because of its elongated muzzle with long fangs. Presumably, this species ate insects, but larger animals had already appeared. In Madagascar, the remains of a huge Vintana certici were found. This herbivorous mammal had a rather unusual appearance. It had massive crests on either side of its skull for self-protection and an excellent sense of smell. The animal weighed 9 kilograms and was 3 times bigger than modern marmots. However, Rhipinomammus was the real giant among the mammals of the Cretaceous period. It had a 1-meter body and weighed 12 to 14 kilograms. Outwardly, Rhipinomammus resembled the modern Tasmanian devil or a squat dog. Its predator even hunted small or newly hatched dinosaurs. And yet, dinosaurs were the pinnacle of prehistoric evolution. They were at the top of the Mesozoic food chain. A great number of dinosaur species of various sizes populated all continents. One of the smallest was Oculudentavis corngray. The head of this miniature reptile was no longer than 14 millimeters, beak included. Unfortunately, paleontologists have not yet found the bones of the torso, but given its head size, this dinosaur wasn't bigger than a modern hummingbird. According to some estimates, one of the largest animals that has ever lived on Earth is Alamosaurus. These dinosaurs were 29 meters tall, weighed 38 tons, and had a 12-meter long tail. 5 hours till the impact. The day terrestrial life was changed completely. All animals, young and old, were going about their day as usual, foraging and hunting. A herd of 50 Alamosauruses went to the Yucatan Peninsula, looking for some fresh greenery. These giants were herbivores. They had to consume up to a ton of vegetation per day to stay in shape. It could take them a few days to eat the leaves from an entire forest, which made them lead a nomadic lifestyle. A middle-aged, predatory Tarbosaurus, living on the territory of present-day Mongolia and China, was also looking for food. This 14-meter-long species is considered the largest among the predatory dinosaurs of the Cretaceous period. Tarbosaurus set out to hunt for prey in the floodplain. Medium-sized animals and small dinosaurs would often come there for a drink, so the hunt was likely to be a success. Like any Tarbosaurus, this reptile walked on 2 hind legs. Its 2-fingered forelimbs were disproportionately small relative to the rest of its body, yet they were very helpful in holding prey or catching fish with their long claws. Tarbosaurus's main weapon, though, was about 6 dozen long, sharp teeth reaching up to 85 mm. 3 hours till the impact. Meanwhile, an adult Pachycephalosaurus was also going about his day in North America. This 4.5-meter long dinosaur weighed about 450 kilograms and looked quite formidable. Its skull was protected by 25 10-meter thick bone dome that surely softened blows when the great reptile fought its enemies. The back of the dome had bony projections, and short spikes protruded upwards from its muzzle. Pachycephalosaurus was primarily herbivorous. It crushed leaves, seeds, and fruits with its relatively small, sharp teeth. However, it appears this dinosaur also included meat in its diet. It ate small amphibians, shell-less animals, mammals, and perhaps even newly hatched dinosaurs. On this day, our Pachycephalosaurus got closer to the ocean, where it found many trees with nutritious seeds. It could also eat plenty of huge ammonite mollusks, lizards, and other critters in small lagoons. Meanwhile, a female Ankylosaurus went into the forest to grab some lunch in western North America. She was guiding 4 newly hatched cubs. This reptile looked like a nightmarish chimera. It reached the size of a rhinoceros, or even an adult African elephant. The body of this tetrapodal monster was covered in powerful bone armor, and it had a massive, club-like knob on its tail. But despite its intimidating appearance, Ankylosaurus was a harmless herbivore. The mother with the cubs didn't seek to kill anyone with her club. The tail served to protect against predators and cannibalistic reptiles. And so, being protected by their mother's formidable tail, the family went into a thick forest near the newly formed Rocky Mountains. 2 hours till the impact. Meanwhile, a real massacre occurred between young reptiles in North America, hundreds of kilometers away from the site of the impending disaster. An absent, Indid Carnotaurus wandered into the territory of a Tyrannosaurus rex and didn't notice the owner in time. At a speed of up to 50 kilometers per hour, the Carnotaurus could have easily run away from its opponent, who could only run at 40 kilometers per hour, but the Rex came into view too unexpectedly. The intruder's smell had given it away. Rex had an excellent sense of smell compared to other dinosaurs, and in terms of eyesight precision, even a hawk might be jealous of this predator. In addition, the reptile's vision was binocular. Its eyes could look in different directions, and then the input from each eye was combined to create a single visual image. This enabled the dinosaur to accurately determine the distance to its prey. And so, that Rex furiously attacked the enemy to protect its territory and get a delicious meal at the same time. You see, this dinosaur never missed a chance to enjoy the flesh of its own kind. It was up to the Carnotaurus now to fight back. The weight difference was huge. The Tyrannosaurus weighed up to 6.8 tons and outweighed the Carnotaurus by almost 5 tons. Its muscle mass, and therefore strength, was multiple times greater. Even with its horn-like projections above the eyes, the Carnotaurus had no chance to fight off the Rex's super powerful jaws. The Tyrannosaurus quickly tore its opponent to pieces and began its feast right away. It was a great stroke of luck for the reptile. According to some estimates, Rex needed up to 100 kilograms of meat per day. This is equivalent to the daily intake of 3 or 4 lions. As it was preoccupied with lunch, the reptile didn't care to look up, and so it missed the bright light in the sky that was growing bigger by the second. 10 minutes till the impact. The huge asteroid was approaching the planet. In a few minutes, it would kill 75 of all living creatures, causing the Cretaceous Paleogene extinction event. In 1980, scientists proposed a hypothesis that it was the asteroid impact that led to this disaster. Found far more iridium in 66 billion-year-old clays around the world than in layers above and below. This is a very rare substance on Earth, but there's a lot of it in some types of asteroids, which is why iridium is sometimes dubbed a space metal. Scientists suggested that the metal was probably brought by an asteroid in a collision event. 10 years later, another team of researchers determined the exact site of the impact. A crater with a diameter of 180 kilometers was discovered in the Yucatan Peninsula and was named Chicxulub. Its age coincides with the dinosaur extinction. Chicxulub has a large amount of iridium, and as you move away from the crater's center, less and less of the metal is found. In addition, 25,000 animal fossil fragments were recently found in New Jersey quarries. These creatures died on the same day at the end of the Cretaceous period. This was another piece of evidence of the mass extinction that followed the asteroid impact. Minutes till the impact, while our Tyrannosaurus was enjoying its lunch, a 10-kilometer rock weighing several trillion tons flew into the atmosphere. Gravity's pull was becoming exceedingly stronger, accelerating the object to a fantastic speed of 20 kilometers per second. Like a piston, the asteroid squashed one 20-kilometer air column after another. Along with friction, this process heated the giant rock to tens of thousands of degrees Celsius, making it much brighter than the sun. At the same time, the Tyrannosaurus was having a little break from its lunch. It lifted its head up and was blinded by the light of the blazing sky. The dinosaur quickly lowered its head, closing its eyes, but the light was burning them even through its closed eyelids. The heat incinerated the reptile's skin and set fire to the trees and grass around it. A second later, the asteroid disappeared over the horizon, leaving the glowing sky behind. The Tyrannosaurus Rex got a little break, but only for a moment. Nothing was happening for a few seconds, but then the sky got blindingly bright again. The asteroid crashed into the Gulf of Mexico near the northern coast of the Yucatan Peninsula. The energy released by the impact was approximately equivalent to 10 billion Hiroshima atomic bombs. In a second, the asteroid penetrated about 20 kilometers into the Earth's crust. The whole globe was shuddering like 1,000 bells from the impact. To put this into perspective, the relatively recent Krakatoa volcano eruption caused half of a cruise eardrums to rupture on a ship 70 kilometers away. The asteroid's impact was 1,000,000 times more powerful. Furthermore, shock waves rushed in all directions faster than the speed of sound right after the collision. They were so strong that they skinned animals alive, lifted them up into the air, swirled them around and crushed everything, even hundreds of kilometers away from the crater. The heaviest dinosaurs flew like balloons. The Rex sustained a severe concussion and died in an instant. Immediately, the shockwave lifted its body up into the air for several seconds. The wave continued to spread, going around the globe a few times, but even before killing the Rex, the asteroid destroyed the herd of Alamosauruses that we saw previously. The animals were grazing right next to where the infernal rock fell. The dinosaurs couldn't escape the unthinkable heat. It burned everything to the ground, turning animal bones to ashes. Meanwhile, the female Ankylosaurus with her 4 babies was peacefully eating leaves in the forest. They were hundreds of kilometers away from the impact site. However, they died even before the Alamosauruses. The red hot asteroid caused huge fires while passing through the atmosphere. One of them broke out where the family of Ankylosauruses was grazing. The fire instantly incinerated the forest, leaving the reptiles no chance to survive. The asteroid also knocked out 15 trillion tons of rock from the planet and sent it high into the sky. A small portion flew into outer space, while the remaining parts, including house-sized boulders, began to fall back from orbit. At the same time, a glass rain started. It was raining hot, 5-kilometer rockfalls. The stone hail and the scorching rain killed innumerable animals. However, the Pachycephalosaurus who was hunting near the ocean in North America was lucky. It didn't die from fires and boulders falling from the sky, but a bit later, when a gigantic 100-meter tsunami rose from the ocean. To get some idea about its scale, consider the devastating tsunami in Japan in 2011. Those waves were barely 10 meters high. Nonetheless, almost the entire island state incurred losses, but the giant tsunami caused by the asteroid impact went thousands of kilometers deep into the land, flooded almost the entire territory of the future user. Wave traces have even been found in North Dakota. One of these waves took the Pachycephalosaurus under, dragged its body into the ocean and buried it in the abyss. The area of modern Mongolia, where an elderly Tarbosaurus was looking for prey, was thousands of kilometers from the explosion's epicenter. Hundreds of dinosaur species still roamed wooded areas. Meanwhile, the disaster was getting closer by the minute. The asteroid impact triggered a series of terrible earthquakes, measuring up to 11.2 on the Richter scale. The tremors were about 50 times stronger than any earthquake known to humanity. The most powerful, the Great Chilean Earthquake of 1960, had a 9.5 magnitude. Increasing this number by 1 point would mean a 30 times more powerful energy release. The planet was shaking so hard that all the volcanoes woke up and began to erupt. About 70 billion tons of pulverized stones, soot, ash and carbon monoxide rose up as a result of the eruptions. Then, they began falling back into the atmosphere. Friction against the air caused an enormous temperature increase. A huge, hot cloud of dust stormed across the planet, burning everything in its path. It was approaching Mongolia at a speed of 18,000 kilometers per hour. The temperature here rose to 150 degrees Celsius an hour and a half after the impact. All living creatures died. Or rather, almost all creatures. Our Tarbosaurus and several other animals managed to escape by hiding in an underground cave. They could hide out here while the killer cloud passed by. Soon, the temperature began to drop. This was followed by acid rain flooding the Earth because several 100 billion tons of sulfur compounds were thrown into the troposphere along with other rocks. For weeks, sulfuric acid poured from the sky all over the planet. It poisoned the soil and water bodies. A dense blanket of dust, ash, and soot wrapped around the planet after the volcanic eruptions, not letting any light and heat in. Even at noon, it was as dark as at night. The temperature dropped by 28 degrees Celsius. An impact winter set in. When hunger and thirst drove the Tarbosaurus and other animals out of the cave, they saw a world that looked strikingly different from before. It was cold, dark, and deserted. Only decay, fungi, and molds were able to reproduce under such conditions. There was no food for dinosaurs on the planet. Countless animals starved to death. Our Tarbosaurus didn't manage to survive either. Perhaps it was the last dinosaur on the planet. However, one can assume that occasional dinosaur eggs were preserved intact somewhere underground. Young individuals hatched from them after some time. Tiny groups of dinosaurs emerged here and there, but cold weather, hunger, and disease contributed to their final demise. The era of dinosaurs came to an end. The Cenozoic era began. The dust clouds dissipated over the planet over the course of several decades, and heat and sunlight were finally able to reach the surface. Nature revived from the ruins. First, huge horsetails and ferns emerged yet again. They were closely followed by angiosperms and grass. Other animals who had been dominated by dinosaurs for millions of years were ready to march bravely into the new era, mammals. Some of them survived the disaster in underground burrows, others stayed in trees. They had become adapted to extreme conditions, were quick to reproduce, and consumed relatively little food. They were guaranteed to thrive on the renewed planet. The success of mammalian evolution led to the emergence of Homo sapiens, who is now the dominant species on Earth. But we're a long way from setting the dinosaurs' record, as it's only been a few million years since we've conquered the world. Only time will show if people will rule the planet for 160 million years like the ancient reptiles. 66 million years ago, an asteroid as big as Mount Everest was headed on a deadly collision course with Earth. The impact was so devastating that it wiped out the most gigantic, deadliest reptiles to ever roam our planet. But the dinosaurs didn't just die from one big boom. No, they faced a slow, agonizing end. How did this extinction event cause the largest tsunami Earth has ever seen? And what exactly happened after the big reptiles were gone? Hold on tight, we're taking you on the most epic and deadly trip of your life. This dinosaur-ending asteroid is terrifying. Not only was it about 10 kilometers in diameter, but it also traveled incredibly fast, between 10 and 30 kilometers per second. At this point, it was a blazing fireball as it hurtled down to Earth. The air in front of it was compressing and heating up to unimaginably hot temperatures. Just before the impact, the asteroid could have been as hot as the surface of the sun. Once it entered our atmosphere, it only took this massive space rock a few seconds to reach Earth's surface and alter the course of life forever. As the asteroid slammed into Earth off the coast of where Mexico is now, it sent huge amounts of debris up into the air. The shocking blast wave killed everything in its way, and from here, it was only getting worse. Yeah, 66 million years ago, Earth was going through some rough times. Right now, our planet's not facing a giant asteroid, but we are facing increasingly severe environmental crises. If you think it's time to fix our planet, well, stick around for a fantastic video recommendation from our friends at Planet Wild. You don't want to miss it. This powerful blast ejected bits of the Earth's surface into the atmosphere, and minutes later, scorching hot pieces of glass and rock rained back down. Some of the debris reacted with the atmosphere, causing acid rain that would last for years. The land was burning. The fires caused by this devastating impact spread across the continent like literal wildfire, killing more and more life along the way. And then, just when you thought the apocalyptic scenario couldn't get any more intense, well, it did. The impact of the asteroid hitting Earth was so powerful that it sent shock waves through the planet, and all that energy had to go somewhere. Cue the mega tsunami. A wall of water over 10 meters high raced across the ocean. This wasn't your regular tsunami. It was a staggering 30,000 times more powerful than anything you see today. As this monstrous wave spread across the North Atlantic and South Pacific, coastlines didn't stand a chance. The wave hit with such force that it destroyed and reshaped the continent. If you were there to witness this apocalyptic destruction, well, you wouldn't survive any of it. But some dinosaurs did. Yeah, the ones further away from ground zero weren't immediately obliterated by the impact. They weren't incinerated by the resulting infernos, and they managed to avoid being swept away by the mega tsunami. But still, their fate was sealed. As the dust began to settle, it was the start of a nuclear winter. Even though it wasn't nuclear weapons that caused it, the effect was the same. The massive amount of debris in the air blocked the sunlight for months, maybe even years. Earth suddenly became a cold, dark place, and the dinos weren't ready for it. As temperatures plummeted and fires released enormous amounts of greenhouse gases, the climate changed dramatically. Plants weren't able to perform photosynthesis, and most of them started to die out. This disrupted the food chain and starved many of the animals that survived the impact. And remember the acid rain. It lasted for several years, causing more devastation to the ecosystems. The oceans became too acidic for marine life. Most ocean species didn't have the time to adapt to such a drastic change. These prolonged, harsh conditions, together with the initial blast, pushed about 75% of Earth's life to extinction. The good news is that this included the horrifying X. Yeah, as much as I feel bad for this guy, I'm happy he's not running around today. When the last of the dinosaurs breathed their last breath, Earth became an empty, devastated place, cold and acidic. So, when did things get back to normal? Yeah. Well, here's the thing, they didn't. Not dinosaur-era normal, anyway. Earth didn't rebuild after that, it reinvented itself. 1,000 years later, the planet was recovering from the post-apocalyptic winter. It was still cold, and food was still scarce, but life was ready to make a comeback. In this new, wild world, a few furry little critters were sprinting around. Among the first plants to reappear after the impact were ferns. They really hit it off well after the disaster. 100,000 years later, Earth began to get a little more lively. Creatures about the size of raccoons were repopulating the continents, and the oceans were once again teeming with life. Fast forward about 10 million years, and Earth had finally restored its biodiversity. Only it wasn't the same Earth as it used to be. Now, it was the age of mammals. Yeah, after the dinosaurs checked out, mammals were on fire. Yeah, not literally, of course. Mammals, together with birds and flowering plants, were rocking the planet. Yeah, Earth never got back to its old self after the last dinosaur died. It took our planet millions of years to bounce back in a new way. But don't get me wrong, this world was still pretty terrifying. It had beasts like Paraceratherium roaming the land and megalodons raining terror in the oceans. Yeah, it's really for the best that most of these creatures aren't around these days. You wouldn't want to face a meg when you're out there swimming in the ocean. Even without bloodthirsty megs sneaking around the oceans, today's Earth and its natural environments face a lot of problems. But it's not game over for our planet just yet. Check out this new YouTube channel, Planet Wild. These guys are like real-life Avengers, going out there to protect our planet. Only instead of fighting otherworldly threats, they stay on this planet and get their hands dirty, rewilding it and fixing the damage we've done to our home. Every month, they release a video. In these ones here, they clean up the ocean from deep, e-waste or transform a dying forest into a beautiful, strong ecosystem. It's an absolutely inspiring journey, one that'll make you feel like you want to change the world. Big shout out to Planet Wild for doing amazing work and for encouraging all of us to do better. Don't wait. Check them out. Let's save the planet and not go extinct like the dinosaurs. Our world was once dominated by dinosaurs. They walked where we walk. They drank the same water, breathed the same air, and fought on the same battlefields. But then they faced a day that none of us can imagine. Some of the most critical hours in the history of life on Earth. This is the story of the day their world ended, the last day of the dinosaurs. Earth 65 million years ago, a warmer place than it is today. Along the west coast of what's now British Columbia, mountains tower over a lush, forested valley. It's the domain of the ultimate forms of prehistoric evolution, dinosaurs. At more than 160 with a wingspan of 12 m, Quetzalcoatlus is the largest flying creature of all time. A kilometer down, a breakfast no carnivore can resist. It will take this tiny hatchling 18 years to become the age's most fearsome predator. But for now, Tyrannosaurus rex is just a few centimeters tall, not very scary and completely exposed, but not completely unprotected. The father, a fully grown X, is on the hunt. His acute sense of smell helps him sniff out prey from great distances, and it also serves him well as a parent. He knows when something is wrong. Quetzalcoatlus's metabolism demands that it eat regularly. Empowering this streamlined body means finding rich sources of protein, like a 1-month baby to X. Quetzalcoatlus' huge wings are perfectly adapted for long distance gliding, but its sheer size makes it hard to lift off when it's backed into a corner. It's lucky this time of the entire clutch of T-Rex eggs, only one chick survives, and if it grows up, it will grow to be 5 meters tall and weigh more than 7 tons. But surviving to adulthood, even for Tyrannosaurus rex, isn't written in stone, because a storm is coming, born of events that took place long before. This is the asteroid belt between Mars and Jupiter, 320 million away. Billions of rocks, all hurtling through space in the same direction like traffic on a freeway, all except this one, which is moving diagonally on a completely different course. It's like a 65 semi suddenly slicing across the highway, but this truck is going 35,000 km. The two asteroids shatter into millions of fragments, but this fragment, over 10 km across, has a special destiny. It's a rock poised to change history because it's heading for the 5th largest planet in the solar system, the only planet known to harbor life, planet Earth. Meanwhile, the planet's reptilian lords live completely unaware of what's heading their way. Triceratops are among the most widespread dinosaurs in what's now Canada. They're herbivores, but that doesn't mean they're wallflowers. Male Triceratops take their mating rights very seriously, and, up to 6 tons each, a face-off can be fatal. This time, intimidation does the trick. There's another enemy waiting in the wings. He's not after mating rights. The Triceratops is fast and well, armored enough to stand a chance against Rex, but not against 2 of them hunting as a pair. One Rex could get behind the deadly horns and armored collar. There's enough meat here to feed them both for weeks, but they may not have the time to enjoy it. 400,000 km is Earth's last hope of defense. The moon has saved the planet before. Its pockmarked surface bears the scars of countless collisions. This crater, known as Tau, is more than 80 km wide, created by a rock only half the size of the one that's on its way. But the moon is rarely in the right place at the right time. Nothing can stop the asteroid now. This cosmic missile isn't as alien as it seems. The Earth itself, it's made up largely of rock and water. In the cold vacuum of space, the water freezes into a hard permafrost, but on the inside there's a chemical cocktail composed of carbon, hydrogen and oxygen, key ingredients for life. Asteroid fragments like this one may have provided the building blocks for life on Earth, life that evolved into dinosaurs. But what gives life can also take it away. Most dinosaurs in the valley hunt and forage during the day and sleep at night. This giant herbivore, an Ankylosaurus, keeps one eye open for predators. Under the cover of darkness, very different creatures emerge from their hiding places, like Didelphodon, a primitive mammal about the size of a possum. Like most other mammals, Didelphodon's life is all about being where the dinosaurs aren't. It only comes out at night to forage for tasty roots and insects. While the giants sleep, it's the meek that witness a cosmic event, a meteor shower. Each streak of light is a tiny fragment of the asteroid collision, burning up as it enters the atmosphere. But these are mainly outriders of the much larger missile hurtling through space, an asteroid locked into a head-on collision. Day of reckoning is here. After a journey lasting 100 million years, an enormous chunk of cosmic rock is approaching the end of the line, and the end of the line is Earth. In what is today central Mexico, a herd of Alamosaurus is wandering the plains in search of food. They are recent species to evolve, and even by dinosaur standards, they're huge. They're the last of the sauropods, the biggest animals ever to walk the Earth, 20 meters long and a staggering 12 meters tall. Alamosaurus weigh up to 30 tons. To maintain that bulk, They need to eat up to a ton of leaves every day. A vast herd like this one strips the landscape of vegetation in just a few hours. Because she's a nomad on a constant search for food, when it's time for this female to lay her eggs, she doesn't nest. She simply lays eggs in groups of 5 or 6 to improve the chances that some will survive. Under normal conditions, only 1 in 3,000 will produce a mature Alamosaurus. But the odds stacked against these eggs are about to get astronomical because now, just 20 minutes away, 2 trillion tons of rock is racing right at them. Asteroid fragments' enormous mass is only part of the threat. The other part is velocity. But as it gets closer to the planet, the Earth's gravitational pull gets stronger, and the asteroid accelerates past 65 to 72,000 m, and mass times acceleration equals force. As the asteroid encounters atmosphere, friction turns it into a fireball, swooping over the Atlantic and aimed at Mexico and the Alamosaurus. It takes just 4 minutes to cross the ocean. It crushes and superheats the air surrounding it, transforming gas and debris into white, hot plasma. At 20,000 degrees Celsius, it's burning brighter than a million suns. It takes just 5 seconds to flash through the atmosphere. Impact seems instantaneous, but hidden within the cataclysm are a series of discrete events, invisible to the naked eye, but key to understanding what follows. The asteroid's trajectory is shallow. It flies in at about a 30-degree angle to the surface. This means the full brunt of its destructive power will be thrown to the north of the impact point. Even before the fireball touches down, its sheer brightness in the sky is unattainable. 800 from ground zero, the light is so intense it makes the Alamosaurus flesh seem transparent and burns flash frames of their shadows onto the ground. The scorching light sears their eyeballs. They have no way of seeing what's headed their way, but they can feel it, an explosive force of 100 million megatons, more powerful than all the nuclear weapons ever built. If the asteroid had crashed into deep ocean, some of the force would have been absorbed. Instead, it hits the shallow waters of the Gulf of Mexico, which instantly vaporize. In a fraction of a second, the entire asteroid disintegrates into the planet. Earth and rock also vaporize and are hurled skyward at 15,000 km. Behind them, 120,000 cubic km of the Earth's crust explodes from the ground. 800 km from the crash site, the air temperature now reaches over 300 degrees Celsius, hot enough to boil away the water in the dinosaur's skin, which escapes in sudden bursts of steam. The fiery blasts suck every drop of moisture from the vegetation. Anything directly exposed to the blistering heat is simply broiled alive. Just 108 seconds after impact in the Gulf of Mexico, the bright streams of vaporized rock can be seen in prehistoric British Columbia. Their clifftop roost, a breeding pair of Quetzalcoatlus, can see the glow of the fireball high above the horizon, 5,000 km away. That's how big it is. Just 2 minutes have passed since the asteroid slammed into the Earth. The body count back near the crash site is immense. Surprisingly, there are survivors. Those lucky enough to be shielded by a mountain are spared the worst of the light and heat blasts, but 3 more waves of destruction are coming. On impact, boulders the size of buildings rained down, blasted into the air at supersonic speeds. But what goes up must come down. Hundreds of surviving Alamosaurus are bombarded from above. A second wave hits from below, an earthquake measuring 11.1 on the Richter scale, nearly 60 times more powerful than any earthquake humans have experienced. The third wave is the blast pulse wave, radiating outward in a perfect circle, packing a force that rips through air faster than the speed of sound, stripping skin from flesh, flinging 30 and dinosaurs into the air like so many rag dolls. 5 minutes have passed since impact, and 3 waves of destruction have decimated an entire species. Many other species of dinosaur in the region share the Alamosaurus fate. Most of the eggs, too, have been destroyed. And yet, the Earth is a powerful protector. Some eggs buried in the cool ground have survived. New Alamosaurus life is growing. There is still hope for now. An immense boulder the size of Mount Everest crashes into the Gulf of Mexico, driving entire species of dinosaurs to extinction in less than 5 minutes. But the worst is still to come. On the other side of the planet, there's still no sign of trouble. Mongolia is 12,000 km from the impact. The scrubland here supports hundreds of dinosaur species. The family of Corythosaurus, it's business as usual at a favorite watering hole. They can weigh 4 tons and grow to 12 meters in length, but they're vegetarians and docile except when they have to defend themselves or their offspring, which are now at their most vulnerable to the hungry predators that lurk around every corner. armed with a razor-sharp, oversized claw on its hind feet. This is the jackal of the Cretaceous period, Sauronithoids, a very smart reptile. Its brain, to body-weight ratio is among the highest of any dinosaur. It's hungry, but it knows better than to take on a full Roman Corythosaurus, not when there are easier targets. In its rush to eat, the thief doesn't get as far away from the enraged mother as it should, and it can smell its mistake. It's a Mexican standoff between two very different kinds of dinosaur. One has the speed and smarts of a carnivore, but the other is 80 times larger. But the large herbivores of this world aren't made for fighting, and that's exactly what the Sauronithoids is counting on, especially when he's got backup. Speed and strategy give these small hunters the edge. But neither great size nor great intelligence is any guarantee of safety from the kind of enemy that is now approaching. On the other side of the planet, a fireball rises 160 km above ground zero. 70 billion tons of pulverized stone and earth fill the upper atmosphere with a cloud of microscopic dust and glass, and it's spreading fast. This is the ejecta cloud. As the dust spreads at high altitude, trillions of tiny particles re-enter the atmosphere. The friction creates intense heat, an 800-degree dust cloud heating up everything beneath it. From their cliff-top perch in prehistoric British Columbia, the male and female Quetzalcoatlus have a clear view of the approaching cloud. Down in the valley, a thick ocean fog blocks out the sky. The heavy blanket of moisture makes it impossible to see the coming apocalypse, but the animals down here do get a warning, not from above, but from below. When the asteroid struck, most of the energy is deflected out or up. Only one of the force travels down into the ground, but it's enough to ring the planet like a bell. Seismic waves radiate both across and through the Earth. 16 minutes and 40 seconds after impact, they reach British Columbia. In the valley, the ground shakes as the 11.1 earthquake ripples through the ground. Triceratops panic up the side of the valley in a desperate attempt to escape the tremors and falling debris. Smaller animals take shelter underground. Meanwhile, the ejecta cloud is approaching at 16,000 km. It bakes the Earth with unrelenting heat. Millions of volts of static electricity charge the cloud like a giant battery, creating a vast electrical storm. Superheated rocks shower the valley, a burning hail. The Quetzalcoatlus are fleeing the quake's devastation below, but there's no way to hide from a rain of fire. Only the valley floor can provide shelter, but they're too big to descend quickly until the male's tattered wings can no longer keep him aloft. If his mate doesn't find shelter, she'll be next. On the mountain slopes, a pair of Triceratops emerges above the cool sea mist. They're almost out of the quake-ravaged valley when the ejecta cloud arrives like a blowtorch. A dinosaur paradise just hours ago, North America is now a living hell. But the ejecta isn't finished yet. Not by a long shot. Less than an hour since the asteroid impact, hundreds of species of dinosaurs lie devastated across the Western Hemisphere. The ejecta cloud continues to spread at high altitude. As it spans the globe, the effects on the ground vary dramatically. 12,000 km away in Asia, the cloud rolls in silently from the east. In Mongolia, temperatures on the ground tick upwards a few degrees hotter every second. There's no audible warning, only mounting heat. As the air reaches 50 degrees Celsius, the only hope is shelter. At 70 degrees Celsius, survival is measured in minutes. Over 90 degrees Celsius, just seconds. 90 minutes after impact, the temperature on the ground in Mongolia peaks at 150 degrees Celsius. But not every dinosaur is baking alive. The microclimate of a cave can keep a handful of survivors cool enough to breathe, but it's a refuge that has to be shared, forcing an uneasy peace between sworn enemies, one that's already fraying at the edges. In prehistoric British Columbia, the dense fog still shields the valley from the intense heat above. In sheltered areas like this, small pockets of dinosaurs hang on. For the Triceratops here, the high temperatures and humidity force them to keep moving. For scavengers, there's no shortage of food, but most animals caught by the ejecta cloud aren't so lucky. The female Quetzalcoatlus is one of the few survivors of her species. The last thing these animals need is a new threat, but the after effects of impact are just getting started. Above the valley and across North America, the intense heat of the ejecta cloud has ignited fires. Blazes so intense they generate their own winds. Down in the valley, the air pressure plummets, creating a vacuum that sucks in the flames. Dry vegetation goes up like a powder cake, building a wall of fire. The front of the fire burns hottest and fastest, moving across the valley floor at 15 km/h. Rex can run twice that speed, but it can't keep the pace up forever. The valley basin is now a firestorm, 1,000 degrees Celsius, hot enough to melt solid aluminum. The panicked animals race up the valley slopes, but fire goes faster uphill. Some lucky creatures escape below the flames, but large dinosaurs have no place to hide. Her wings, still damaged from the falling ejector, the wounded Quetzalcoatlus struggles to take off. For the dinosaurs, time is running out. 2 hours after the asteroid impact, the entire planet is covered in dust and smoke. Fires rage across the Western Hemisphere. One of the few remaining Quetzalcoatlus, a flying pterosaur as big as a giraffe, is struggling to get airborne. From above, what was once a lush valley is now an inferno. Animals that fly can escape the flames, but there are few places to land, and almost nothing to eat. Food chain once rich enough to support giants now lacks its basic component, plants. 12,000 km away in Mongolia, the temperatures are finally dropping. A handful of animals remain safely holed up in their cave. It seems the worst is over. The ravenous ornithoids can't resist the sight of an easy meal. Soon, the braver Corythosaurus follow, making their way back towards the watering hole. One stays near the protection of the cave as the ejector begins to clear. The parting clouds reveal the shift in temperature is throwing Earth's weather systems into turmoil. And in Mongolia, powerful winds are gathering billions of tons of dust and sand. A dust storm forms as hot air rises. Thermal imaging shows how it builds, whipping up loose particles of sand and dust and gaining energy from the heat of the sand itself. The 150-degree temperatures that baked Mongolia turn a common weather phenomenon into a superstorm. As it hits, the Sauronithoids are small enough to crouch for cover, but the Corythosaurus are out in the open. The sand blasts their bodies. The harder they struggle and the deeper they gasp for oxygen, the more sand fills their lungs until finally, they can't breathe. Superstorm engulfs much of the continent. It's hours before the winds die down. The last Corythosaurus, protected once again by the cave, heads to the watering hole on her own. Halfway there, she finds she's the last of the herd, but she's not the last remaining dinosaur in the neighborhood. Huddled close to a Corythosaurus corpse, the Sauronithoids were sheltered from the worst of the storm, but the sand has swallowed their meal. Instinct drives them back to their prime hunting spot, the watering hole, where the last surviving Corythosaurus is taking in the much-needed fluid. She's lucky to be alive, but too exhausted to run from any new sign of danger. And danger has arrived. The Sauronithoids are desperate for food, but they're weak from hunger and the buffeting of the sandstorm. Only one has the confidence to attack. Its prey is still too exhausted to run. But this time, size does matter. Remaining Sauronithoids moves in, but it has no intention of making a run at the Corythosaurus, not when fate offers it a meal that can't fight back. A week after impact, food is in very short supply across the entire planet. Life is hardest for the plant eaters. Huge herbivores have to eat vast amounts just to sustain their massive bulk, but there are simply no plants to be found. They can only hope that something, somewhere, is growing. The carnivores are more fortunate. They can eat the herbivores. But 2 triceratops are a little too much to take on for now. 3 days after the asteroid impact, a once blue planet is shrouded in darkness, and the landscape is anything but green. Fire, heat, and acid rain have battered the terrain until it's unrecognizable. Normally, triceratops wouldn't travel more than a few miles a day. They wouldn't have to, but now most of the continent is stripped of vegetation. Hunger drives the giant herbivores toward the Pacific coast. The devastation reaches all the way to the sea, but geography has a way of protecting certain places from cataclysmic events. In this case, an island apparently untouched by the surrounding desolation. There may still be food here. The female Quetzalcoatlus has been flying for 3 days. She's weak and in desperate need of food. From 300 meters up, the island comes into view, but all is not as peaceful as it seems. Deep below the surface, the ocean floor was shaken by the asteroid's initial impact. Sedimentary rock disintegrates under the strain and collapses hundreds of meters into the ocean floor. On the surface, sea level plunges, triggering a massive swell at the coast. The ocean is dragged back hundreds of meters from the land, exposing huge expanses of seabed. Exposed land suddenly creates a path. to the island. The forest ahead of them appears untouched by the hellstorm of the ejector. It seems too good to be true. A kilometer from the coast, the three Triceratops finally reach the promised land, sheltered from the ejector by sea mist and protected from fire by the surrounding ocean. The island has all the food they need. The Quetzalcoatlus hasn't had a decent meal in days. The asteroid has awakened the ocean's most destructive force, a mega tsunami, a wall of water 100 meters tall. Within seconds, the land is deluged, and as quickly as it came, the flood is gone. But this is only one in an immense army of mega tsunamis. The asteroid impact launches them against more than 20,000 km of coast. Huge swaths of shoreline simply wash away into the sea. The avalanche of water leaves countless dead in its wake. But as devastating as the first wave of disasters is, there's more to come. In the days following the asteroid's arrival, a series of plagues have been unleashed on the planet: firestorms, earthquakes, sandstorms, and towering tsunamis. These are only the outward signs of a catastrophe that reaches much deeper. Across the continents, thousands of dinosaurs may be walking, but their species are already dead. Because to survive, any species needs to maintain a critical mass of population, fall below that threshold, and there's no way to climb back from certain extinction. The final nail in the coffin may take a while to develop, but it's no less deadly and no less final. The coup de grace for the dinosaurs comes from inside the planet. Because when a rock 10 macro slams into the Earth at 72,000, it shoots 1 million megatons of energy straight into the ground. Seismic shock waves ripple through the planet. The aftershocks continue for months as tectonic plates shear and tear deep inside the planet. They trigger molten rock to force its way to the surface through newly formed fractures until it explodes from the Earth's crust in violent volcanic eruptions. The seismic waves awaken dormant volcanoes around the world, adding to the debris clouds of dust and toxic gases that already surround the globe. The shroud is already many kilometers deep, a thick blanket stopping light and warmth reaching the Earth's surface. The planet plunges further into a nuclear winter. In the days and weeks that follow, the only growth to thrive is fungus, which lives off the rotting remains. Here in Mongolia, few signs of dinosaurs remain. And for the starving Corythosaurus, the future looks bleak, but it stays near the cave that has saved it twice in the past, the watering hole that once provided plenty. But the last Corythosaurus doesn't fall victim to starvation. Bubbling to the surface is one of nature's most toxic gases, hydrogen sulfide, released from deep underground by volcanic activity. Collects invisibly in low-lying areas, like the watering hole's natural basin. The gas paralyzes the lungs, making escape impossible. Then it kills by suffocation. What was once a refuge is transformed into a death trap. The last dinosaur in this part of Mongolia is dead. Mexico, too, is a graveyard. Just 800 km from ground zero, it's been hit by wave after wave of devastation. There would seem to be little else that nature could throw at it. And yet, amidst all this destruction, beneath a thin layer of charred soil, a lone Alamosaurus egg survived. In what's now British Columbia, just a handful of dinosaurs patrol the grey wasteland. An Ankylosaurus searches the charred terrain for something to eat. 7 meters long and weighing 4 tons, this heavily armored herbivore is used to getting nearly 135 kg food every day. All it can find now is a small bush, and even that won't come without a fight. Suddenly, hunger isn't their biggest problem. Here. The Ankylosaurus' main defense weapon is a heavy-tailed club, but it's too weak to get in a good shot. Took 160 million years to bring the dinosaurs to this point in their evolution. It took just one rock to bring them down. The events triggered by the impact flashed by at breakneck speed. Seismic shocks caused massive earthquakes. Boulders the size of buildings rained down, followed by a brutal blast wave, all within the first 3 minutes. By the time the superheated ejector cloud hit Mongolia just 44 minutes later, the whole planet was in shock. In the coming days, forest fires razed the earth. Violent dust storms destroyed entire ecosystems. Titanic waves wrecked coastlines. But all these together, and it's hard to believe that anything on Earth could have survived. But something has. Mexico, 800 km from the point of impact, the very first landmass to feel the force of the asteroid strike, a region that has suffered wave upon wave of violence. Yet even here, even now, life remains. The last surviving Alamosaurus egg, buried safe within the soil, a chick has survived the barrage of destruction, and he's not alone. All around the world, small handfuls of dinosaurs try to start over, but inbreeding and disease weaken their tiny populations. Eventually, the huge numbers of dinosaurs that had ruled the world are reduced to a single, solitary dinosaur. Then it too is gone, and with it, a dynasty that had ruled the Earth for 160 million years. But dinosaurs weren't the only animals on the planet. There were other, humbler life forms that had lived in the dinosaurs' shadow for a very long time. When floods and firestorms hit, they found shelter underground. Some hid deep inside trees and plants. Others took refuge beneath the soil. Small mammals, like Didelphidon, survived by scampering into burrows. Down here, they were protected from the worst the asteroid could throw at them. The Earth would be inherited by animals that were good at hiding. Fish were sheltered beneath the water. So were the aquatic reptiles. Birds, especially waterfowl, could survive by diving underwater or hiding in burrows. It would be years before all the sun's energy could reach the land again, but the heavy cloud slowly begins to clear. In the Gulf of Mexico, where the asteroid struck, a shallow crater can be seen. A tiny scar for such a fatal wound. Out of the ruins, nature starts over. Simple organisms like mold and fungus dominate the burned and rotting landscape. Then, new growth emerges, and one plant in particular, ferns. Tough and resilient, they soon carpet the planet in green. It takes thousands of years for ferns to give way to forests, breathing oxygen and life into the planet again and setting the stage for a new era. Because waiting in the wings are creatures whose development had long been thwarted by the dinosaurs. The mammals, unlike the dinosaurs, are fast breeders, brilliant adapters. They multiply and diversify, 10,000 species exploding across the planet. It's millions of years before one very important species branches off from its relatives and comes down from the trees. They walk on two legs, evolve bigger brains, and eventually rule the planet, just as the dinosaurs once did. But unlike them, they'll reshape the world, building cities that touch the sky, vehicles that can leave the planet, and weapons that can destroy it. But none of it could have been possible if a chance collision in space 165 million years ago hadn't sent an asteroid hurtling toward Earth and doomed the dinosaurs to extinction. Only because they died can human beings live.